a table that shows the mean monthly maximum temperatures increase. Lovely. Use a sine function of the form t is approximately. Now notice here they'll use this symbol because it's not exact. Okay, so we are modelling it, so it's not exact. We think it's approximately using this. Okay, and to model the data. Find good estimates of constants A, B, C, and D without using technology. Right. I would suggest the first thing we probably want to do here is to draw this graph. Okay? Now, I know you've just got blank paper in front of you. Let's do the best we can with, do you know, it's been about this for the next few weeks. Really? Just a noise.
Oh, the vertical
yeah, but
that's what that's what they're probably like it.
That's why they blocked off that's what they're doing. So we're gonna sketch this. So you're gonna draw an axis of it as best you can. So obviously our vertical axis, our maximum value is 27.
Is that too big?
No. I'm going to say 28 because I like even numbers. I'm a bit weird. And the minimum value is 14. So you probably you don't need to go down to 0 when you're drawing these. So you probably want from 14 to 18. You do, but if you don't go down to 0, remember you need that heartbeat thing to show that you haven't started at 0. And then your horizontal axis is obviously going to start with 1 and go up to 12, I think. Yes, because they've said to use Jan as 1. So this will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you're going to plot something, try and make it even-ish with your scale, and plot this. Right, so having plotted our points, we now need to try and establish what our parameters are. So what value should we have? Or could we have for the A, B, C, and D? Now, you actually have a couple of different options here. Essentially, what we have to remember is the original shape of the sine curve. Okay, do you remember what the sine curve normally looks like?
It makes an S.
Yeah, so it makes an S through here. So remember, what are the 4 points that I've asked you to try and remember? 90,
180, 270, 70, 360.
Good. And what are these values?
70.
What's the maximum value? 1 and negative 1. And so remember, it starts at 0, goes up, down, down, and up. Yes? Do you remember that?
Yeah.
Alright, so that's what our general sine curve looked like if the value of A was 1, the value of B was 1, the value of C was 0, and the value of D was 0. Okay, so that's what it would look like with no values there. But obviously this doesn't quite look like that. Okay? Essentially we've got this thing happening. Now, hopefully you also remember that the transformations of functions. Do you remember that? Where we change functions. So if this was the graph of y equals x squared, what would happen if I had y equals negative x squared? What would it look like? It would be a reflection, yes? A reflection in the x-axis. So having negatives can also change it. So if I wanted to draw the graph of negative sine x, it would look like that. Yeah, you all happy with that? Hopefully I'm not confused anyone yet. So sine x would be the green and negative sine x would be blue. So you've got a choice here. You can see that, well hopefully you can see, that this graph here I could take as being a sine curve starting here and doing that. Yes? Do you all happy with that?
Yeah.
So that would be the green version. Yes? Or I could say, well hang on a minute, I've got my blue option in that I can start my graph here and this would be a negative sine curve. Have I lost you or have I lost you? Okay. Should we just go with this option then? Were you all happy with starting here with the black line?
So if that was like two, if that was like sine 2x, then if you do it negatively, then it was this.
Well, basically, we've got our graph doesn't start on this axis, no matter which one we talk about. Okay, it has had some shifting left or right. Yes. We're all happy with that? It didn't start here at nice 0, 0.
How come?
Because it don't. Because it doesn't. Practically, our things don't always start where we want them to start, or where the norm would be. Okay, so it could be, yeah, it just doesn't always happen that way. Okay. Maybe I'm trying to go too far too soon. Maybe we should just start with the amplitude.
Wait, so when you drew a graph on the corner, is the green squiggly line sine x?
Yes, so the green was just sine x, and the blue was negative sine x. All right, so let's backtrack a little bit, and let's try and find the value of a first. Okay, right, the value of a indicates that we're looking at the amplitude. Yes. So let's go back at this here. So A affects the amplitude. How do we find the amplitude of a graph? Do you remember?
It's from that foot to that foot. The top of the no,
Yeah, come on.
It's from the top of the crest to the halfway.
So yes, so here's the very top. Yes. Here's the very bottom. The amplitude would be actually half of that distance. Do you remember that? So for the green graph, here this was our max, this was our minimum, and it was halfway in between it. Yes. So that was a whole value of 2, and it was 1. Yes. So we're going to have a look to see here what would be our value of A. So our very maximum point. What was our very maximum point?
28.
Or is equal to 27. So amplitude, so we write here amplitude is the maximum, subtract the minimum, divide it by 2. Okay, so we've got 27, and then our minimum value. What was our minimum value? 14, I think, wasn't it? Yeah. 14 divided by 2. So 27 take away 14 is 13, divided by 2 is 6.5. So from this information here, we would predict that our amplitude would have a value of 6.5. Okay? Right, next thing we need to suss out. Well, to be honest, the next easiest value to find in my mind is the value of D. This bit here. Do you remember what that D tells us? No? Anyone? Wait. Oh.
That's not what I was going to say.
So it's a vertical translation. But here we need to know, what does that mean? What do we mean by the vertical translation? Well, on our if we compare it to our original sine graph, try to get rid of the blue one. Try to get rid of the whole thing. Right, so normally our graph would look like that, yes? And remember, I consider this to be our central line, yes? So if our graph has shifted, then our central line has shifted, yes? So where do you think our central line is on this graph here, or how can we find it? It's going to be around here, isn't it? Yes? Yes?
6.5.
Okay, it's going to be, oh my gosh, Jennifer, I love it. It's going to be 6.5 from here, or 6.5 down from here. Why is it 6.5? You just walked in on this, so maybe that's why you're looking at that. Because we knew our amplitude was just 6.5, yes? So to find the value of D, we would say the maximum plus the minimum divided by 2. That's how we find it. Okay? So our maximum was 27 plus 14 divided by 2. So that's 41 divided by 2, which is 20.5, which is what you guys were telling me. It was around this area here. But the nice thing is, you're looking at it thinking, I can see roughly where it should be. So if you have some crazy number here, you at that point were going, oh, hang on, I've done something wrong. Perhaps you subtracted when you should have added, so whatever happened. But you have an idea of where it should be. Yeah? So we found 2 of our values.
Wait, so does the amplitude just give me the A before the sign?
Yes, so this is the A. So we've got our A and our D. But our next thing now is to look at either B or C. Let's look at C. Okay. If we're sticking with the fact that it is our sine curve, then we know our central line here is at 20.5. Yeah, you happy with that? Now, this is what I was trying to ramble on about at the beginning. Here is where our normal sine curve starts, isn't it? We all see that? This is where our normal sine curve starts. It normally goes up, down, and then up again. Yes? But our sine curve has started over here. Okay? So what's happened is it's shifted. So normally it would be starting here on the y-axis, but it's shifted this amount away. Can you all see that? Okay, good. Now, it's shifted over to this point here. We're not using technology, so we can't use any technology to help us. Which value, this is where, it's an approximate, and we want to find a good estimate. So which value would we think? Probably this one here? Yeah. The fact that we wanted 20.5? Yes? You happy with that? So this was 1, 2, 3, 4, 5. Okay? So this happens here when x, or when t was 5. Which means our graph has shifted to the right by 5 units. Now when it's shifted to the right, that means that our value here would be negative. Because it's always the opposite way round. It's a bit annoying. Okay, so because it's actually happening over here, then it would be a negative value. Okay, so our value, so far our equation is 6.5 sine, we've still got a b we need to find, t minus 5 plus 20.5. So far so good? Now, what I was chatting about earlier with the whole negative positive is what we could have said was rather than our graph shifted all this way over here, we could have said that it's just shifted a little bit over here. But in that case, it would be a negative. But maybe I'm just confused. Are we all happy with this bit? Kind of. What's the speed? That's 5. That's the bit we just worked out. So this value here was C, which we decided we were going to put as 5. Alright, so our last bit is B. Now, with trig functions, remember with trig graphs we have an option of degrees or radians, yes? With our application one, you always use radians. Okay, so we always would consider this as being a 2 pi period. So normally our period, so your normal period would be 2 pi. But our period is actually 12. Okay, so our graph has gone through its cycle in 12 units. Oh no, I lost you again.
No.
Yeah.
What?
You're thinking about you say it.
It's just funny.
Oh.
It's pretty high. Cycle.
It was more just a cycle.
Yeah.
It like went along.
You so it's taken 12 units. It's taken 12 units to do our cycle. So if we go back to this thing here, the period is 2 pi over whatever value it is, or in other words, that value is going to be 2 pi over our actual period, which is 12. Oh no, don't mind that. Normal period is 2 pi. So our period is 12, so the value of, is it B? So our value of B is going to be 2 pi over 12. Okay? Which is pi over. So B is this value up here.
How do you just know this?
Here.
Well,
I'm literally a
I know, but like,
Why me?
anything else about it?
I think I got it.
So that's our final equation. So all I've done is my working at the top here was establishing all those different letters, so the A, B, C, and D, and then I just chucked them into my formula. Now, if we were actually doing this, what we would do is we would then use some kind of technology, some kind of graphing package or your calculators, stick all that information in, and ideally you would end up with a graph that kind of looked like this.
How many marks did the question
That's a really good
18.
question.
I love that. Question you ask how many marks.
I said, how many marks are I doing? I really don't know. Let's find some. I'll find some and then we can have a look.
Can I put it into the Y?
Yes, so if you were using your calc, you would stick it in the Y. But hold on, Cameron. So you need to have all the correct mode. So you just got to make sure your mode is correct.
You speak that way over there. Thank you.
Oh, right. Then I'm going to leave it if I just put it up.
Alright.
I'm going to record this. So if we're inputting it into here, we'd be doing it into the y equals bit. But we need to have all the right modes and things. So let's clear everything out. Go into mode and make sure it's in radians, because that's what we're using. So you need to make sure we calculate it in radians. Then when we are doing y, if it goes back to the y equals, this is y equals. And if we go to, I can't actually read this, which is the one that says scale. Where is the scale? I think it's in this one. No, it's not.
Is it a blue? Heart?
Oh. Zoom. Okay, so it's not anything, it's just zoom. Oh, no bug. So in y equals, press zoom. Ha, that's what it was. So remember, this is where you go to change your axes to just stand the one that they have, the calculator has. Which one do you think we're going to use?
Zoom, scan, I don't know.
What kind of graph was it?
Trig.
So we're going to go for number 7. Alright? Now, that does go into the negative part. So what you might want to do then is to go into window and change your x minimum to be 0. Okay? And then you go into the y equals and you plot what we've just plotted. So you do the 6.5, blah, 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 and hopefully it will come up with something that looks like
So our x now